So the AP exam date is Thursday, May 5th, 2022, which is a weird date because every year that I've been teaching statistics for 10 years now, it's been the last either Thursday or Friday in the second week. So I don't know why they changed it to the first week. I'm happy it's the first week. It's fine. But I think that's an interesting move that College Board made. And then the exam is broken down into 2 parts. There's 40 multiple choice questions, answers A through E, and that's 50% of your overall composite score. And there's 6 total free response questions, and that's also 50% of your overall score. So it's actually a really exam to like administer or take because it's not too many like moving parts. I don't know if you guys take calculus, but all my calculus teachers, they have like inactive section, they have active section, they go back to the inactive section, whole bunch of stuff. You get a calculator for the entire exam, you get a formula sheet, and you have an hour and a half for each part. So you have an hour and a half for 40 multiple choice questions, and you have an hour and a half for 6 free response questions. Now the free response questions, there's 5 traditional ones, and there's 1 free response question that's called an investigative task. So the free response questions are, questions that come up in our class, stuff we'll work on. The investigative task is something that's not covered in statistics, but they want us in AP statistics. They want to see how you can take what you've learned and apply it to a new field of whatever. But one thing that's really cool about the investigative task is that you get to do that. You get to apply it to a different field, and they scaffold you really the whole way. And when we do the AP statistics crash course, after we finish our sessions in March, we'll spend some time just practicing the investigative task. When I'm teaching my AP statistics class, which I won't teach them until the spring semester, I don't spend any time during the normal school year doing that. I save the investigative task for the review. And then to the right there is a quick breakdown. There's 9 units. And the way we're gonna sort of roll with it, we're basically gonna do a unit every 2 meetings. Essentially, that's sort of how I broke it up. So we're gonna move at a fast pace, obviously. I think we'll be all right. And you see the multiple choice section weighting. So inference is huge. So unit 6, 7, 8, and 9 is inference. So this is my first year at the early college at Guilford, and I've actually never taught statistics in a block setting in a semester. So when I've taught statistics for the past 9 years in a traditional high school where I have the students all year round, and I would typically spend about 2 months on all of inference. That's going to boil down, I don't know what that's going to boil down to yet in terms of my normal class for this school year, but inference is a huge part of the exam. So we sort of start off basics, and we'll look at some stuff today. We're actually going to really start with something really cool. It's my favorite lesson. I teach this lesson ever since I heard about this, and it's a really cool thing. But that's sort of the outline that I wanted to give you. But one thing that I always pride myself in with AP statistics is that, you'll never ask yourself when you're going to use this in real life, because we're always doing real life stuff. When I'm teaching, like my Algebra 2 class, it's called Honors Math 3, but it's like Algebra 2 when we're dividing polynomials using long division, synthetic division. Like, when are we going to use this? I'm like, you need to get a high school diploma. This is why. This is just the thing you have to do. But I tell them, I said, when you take AP statistics, you're never going to ask that question. It's always real life stuff. So.
Joy Milne first noted something odd about her husband, Cent, when he was 45. Shortly afterwards, he was diagnosed with Parkinson's. Now universities are testing if it's a coincidence or a newfound precaution. Here's Mike McCarthy from our British partner, Sky News.
When she was a teenager, Joy Milne started to realise that she had an acute sense of smell. But it was only when she noticed a change in her husband Les's odour that the incredible potential of her super sense became clear.
He was an anaesthetist. He was in a close situation in theatres, and he was working long hours, and I presumed, and the Parkinson's tiredness had kicked in then, but we didn't know that. And because he was so tired, I just thought, well, you're not showering enough, and I said so.
At first, Joy didn't know what the smell was until she recognised it in other people and said so at a meeting to discuss Parkinson's.
And I thought, this is it. This is the right moment. And I stood up and said, why are we not using the smell of Parkinson's? I can smell it in this room all around me.
Now at Manchester University, researchers supported by the charity Parkinson's UK are harnessing Joy's special skill. Once Joy's incredible ability had been recognised, she was given by the university a number of T-shirts. Now, half of them had been worn by Parkinson's sufferers, the other half by a control group. She got them all right, apart from one.
So really quick, let's just jot down what we do know, right? So Isabella Thomas, why would it be important for someone can smell Parkinson? Why would that be important? She smelled 12 shirts, right? How many would you expect, guys, out of 12 that she would get right if she couldn't smell Parkinson? She was just guessing. What would you expect that she would get?
Based on just probability, it would be 6
Yeah.
out of 12.
Yeah. Why do you say that, Isabel?
There's 2 options she's given. If they have Parkinson's, if they don't, if she only has 2 options and there's 12 shirts, then
Yeah.
there's half chance, so 6.
Absolutely. Thomas, you agree with that?
Yeah.
Cool. All right. Now, do we have some evidence that Joy can actually smell Parkinson's? Do we have some evidence for that?
I think she can smell like 11 of them.
Yeah, Thomas, absolutely. Yeah, because she smelled 11 out of 12, obviously greater than 6 out of 12. We have some evidence that, this person, Joy, she might be onto something. Now, this answer is different for everyone. Thomas, we'll start with you. How many correct decisions out of 12, Thomas, would it take to convince you that she could smell Parkinson's?
All of them.
Wait, all of them. Thomas says all. What about you, Isabel?
I'd say 10 or 11.
10.
Good.
10 or 11. So you are already convinced, Isabel, that she can smell Parkinson's. Done. Thomas is like, nope, I need them all. All right, so let's take a look here. Now, can you smell Parkinson's? All right, so I'm gonna enable the data collection, and then you guys can try it. So we're gonna do the experiment, and I'll do it myself. No rhyme or reason, because we're just guessing. That's what we're starting off by assuming that she cannot smell. Ooh, I got 6 out of 12 with my guessing. And while we're here and while Thomas is doing the activity, I do want to give a shout out to Mr. Doug Tyson. He's a fantastic AP statistics teacher out in York, Pennsylvania, I believe. And he was the original creator of this lesson. So kudos to him for putting this together. And Thomas, you got 7. Very cool. All right. So Thomas, you're the leader right now. Now, obviously, we want to do this more times. So I'm just going to add in, let's add in 27 more. So the computer's going to do this pretty quickly. So we'll get a nice even number. So this is our dot plot after 30 simulations. So what the computer did was exactly what we did, right? Guess using the 50% probability, right, of just guessing and getting it correct, doing that 27 times to get to a nice even 30. So what do you guys think that each dot represents? I sort of just said it, but what do you guys think each dot represents?
Like,
The number. Oh, yeah, you can go ahead.
like each dot is a trial, I guess, like from the person.
Absolutely. So each one of these represents one experiment, right? This one is another experiment. This one is another experiment. And the result on the dot plot here is the number of shirts they guessed and got correctly. So each one of those is a different experiment where we sat down, smelled the 12 shirts, and guessed, right? So that's what's going on. That's a super important thing to realize as we move through this world of AP statistics. So every single one of those represents a different experiment. In this case, it's a different experiment. All right. So based on our observations and the simulated of 30 samples, what proportion resulted in 11 or more correct identifications? So let's go back to the dot plot. How many more were 11 or more?
None.
0, big goose egg, right? There is none over there, right? So that is 0%. 0 out of the 30 different samples did we get 11 or more correct. Now, I will say, out of the 4 or 5 years I've been doing this activity, I always have like one kid that gets like 12 out of 12. And I'm like, you need to go buy a lottery ticket or tell your parents to go buy a lottery ticket because you're really lucky today. So based on these results, right, do we have convincing evidence that Joy can smell Parkinson's?
Considering that from the experiments we did, none of them were 11, and the most were 9. We do have some convincing evidence that Joy can smell Parkinson's.
Yeah, absolutely. Thomas, would you agree?
Like, sure, but like I feel like we need more shirts, I guess, for
More
data.
Yes, that was my next thing. So let me break down to sort of what happened. So far, Joyce, this person Joyce says, I can smell Parkinson's. Everyone's like, whoa, 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 whoa. No, you can't. That's unheard of, right? You guys like superpowers or something, if that's true. So they're like, fine, here's a test. And they make her do a test. And here's 12 shirts, Joyce, smell them. Do they have Parkinson's or not? And she got 11, 12 right. Man, you were probably just lucky. So in statistics, right, I have no idea how likely or unlikely that 11 out of 12 is. No clue, right? So then we use the idea of simulations, right, where we do something many, many times to see how likely our result is, right? So, and this is building up to like to figure out the theoretical probability of observing this scenario, right? And we saw out of 30 times, it never happened, never. But like Thomas said, we need more, right? Maybe not more shirts, but maybe repeat this process over and over and over and over again. And let's see what happens, right? So at this point, I think we have convincing evidence because we observed something that is so unlikely. So we then know that our original claim is wrong. So we start with, assuming Joy is guessing, right? And then we found a 0% probability if with that assumption that she was guessing, right? This simulation is built on the assumption she can't smell Parkinson's, she's just guessing. Well, what we observed shouldn't have happened. But because we observed something that shouldn't have happened, whatever the assumption was, is wrong. But let's look at something really quick here now. Let's see if this video plays.
She got them all right, apart from one. That person went on to develop Parkinson's. Scientists believe that Parkinson's may cause a subtle change in the skin's natural oil and are working to develop a test that could help diagnose the disease even before physical symptoms occur.
This is a significant new area to research into. There are many scientists looking to do early diagnostics. We all want to do that. We want to be able to tell people, unfortunately, but tell them that they've got a disease earlier than is currently happening. If we can find that molecular signature, find a test for it at an early stage, that's when the breakthrough will be. So this is the beginning of the breakthrough.
Joy's husband Les died earlier this year. But the hope is that through science and research, the phenomenon that is her sense of smell will help reverse the destructive power of a disease for which, as yet, there is no cure. Mike McCarthy, Sky News, Manchester. She got them all right.
No, stop playing. Stop playing. Mind-blowing stuff, right? So not only did she get the 11 and 12, the person that didn't have Parkinson's developed Parkinson's later. That is mind-blowing stuff. Now, really quick, I'm actually going to go back and share this screen here. And I'm now going to add in more data. I'm going to add in, so we're at 30. Let's add in 10,000 more. Oh, stop, fine. 2,000 at a time. I'll add 2,000 more. Wow. Take a look at this. So I want to see the number of dots greater than 12, because she got 12 right. One time out of 2,000. Let's add another 10,000. Let's add another 2,000. All right. Let's count it again. 2 times out of 4,030 trials. That is insane. That is wild. So we have really convincing evidence that our friend Joy here can actually smell Parkinson's, because she did something that should not have been true if the assumption was true. Both of you said, you'd expect 6 right if they were just guessing, and look where our center is. That's 6, right? So this is a really, really awesome thing that Joy can do, right? She can actually smell Parkinson's. Mind blown. So thoughts on Miss Joy here? What do you think about that lesson? Is that pretty cool? My kids always get jazzed about it. And this is what AP statistics is about. It's taking something that's unknown, investigating it, and seeing the likelihood of it. It's a really, really fun course. And I always get the question, Mr. Simonetti, what unit did we just do? Because this is the first day of school, right? This is when I always do this lesson. And I'm like, they're like, is it unit 1? I'm like, this is the entire course. The skills that we talked about in this entire thing here, an entire activity, is going to show up throughout the entire course. So hopefully you guys enjoyed it, and you'll get to see the parallels that we're going to connect throughout.